Alright. So, before I begin, do you have questions from last time? Alright. So, last time we were, yeah.
Are we still on chapter 2 or 3?
We're 3 and 4 actually. We talked about classes last time, and we talked about conditional statements. So there's a couple things I gotta talk to you about the if statements. The syntax was if, and in parentheses you write your condition. And if the condition was true, you write here the code, right, to execute if true, and then here you write the code to execute if false, right? So, what happens if I don't want to do anything if it's false? What do you think we should do? Shall we just leave it like this? If I don't want to do anything if it's false. So if you remember in your UML diagram, you had the equation, and if it was yes, you do something. If it was false, no, you do something else, and then you continue down. But if there's nothing to do when it's no, we just draw a straight line like this. There was the no part. So how does it translate to code? You simply don't write an else. Just leave it like that. So there's only a code to execute if it's true. So far so good? What if, let me put it back. What if you only want to execute code if it's false? Can you just erase the if and just leave else? Because there's nothing to test if there's no if portion, right? I guess you could leave the space blank there, but that would be really sloppy. So, reviewing the logical operators, you remember we did that equals, greater than, greater or equal, less than, less or equal, and not equal. Remember those? So, let's say my condition is there's many ways to do this. Let's say my condition is x greater or equal than 60. But I only want to execute if that's not true. What shall I do? sorry, what?
Can you put like a null up to that?
Null, what does null mean? It's zero address, right? Null is just an address pointing nowhere. So it wouldn't be a null. If I only want to execute if it's less than 60, just do that. Just change it to less than 60. No big deal. Or if I had it like, that's why it was important, and that's why I asked you what were the opposites. So if I had it like this, this whole thing, this expression returns true or false, right? So, does it make a difference if I do this? No, right? Still returns true or false. But I can do something here. I can say equals to true. So I compare true equals to true, or I can do this, not equal to true. Or I could do equals false. You can do whatever you want. So going back the way I just had it before, I had it like this. I said not equal to true. Right? That's what I had. And that basically, if I had the UML diagram, if it's no, I do something. Now, questions? So I said not equal, right? So this thing, the exclamation mark, has a name. Call it not. Okay. So not equal. Right? So, what does the not do? It reverses everything. It's like when you were a kid and you say, hate you not, we say it first. We said not first. So, we know that returns true or false, right? But if we want to do only something if it's false, we can also put a not in front. So if this returns true inside the parentheses, says the not, so it will turn into false. And if this is false, inside the parentheses, it will turn into true. So it'll say not false or not true. It gets sometimes confusing, so I avoid doing nots a bunch of times. But you get the idea. Any questions? Alright, so let me erase this for a second. Alright, assuming assuming that you want to retire, that's the example we were doing last time, and the retirement age might be different based on the gender. Just an example. So let's say for males 65, for women are 60. So we got two things to test, right? So for the age, what kind of variable will you use? We're using an int, right? You don't say I am 25.6 years old, right? You just say I'm 25. When you're a kid, yeah, you do that, right? Because you want to sound older. But, alright, so this is your age. So, what about the gender? What kind of variable will you use? You will use a string. So, how long can a string be? How many characters a string can hold? 2 to the 16. That is 65,500 and something. And you're gonna hold, how many values you wanna hold there? 2. So a string will then be appropriate. So what kind of variable will you use? Is there a variable that only holds 2 values? Which one? A character? Okay, if you hold a character, how many bits is a character? 8 bits, right? So how many combinations do you have? 2 to the 8. So if I say gender equal male, or gender equal capital M, are those the same? Because they're different ASCII values, right? What if I say gender equals question mark? Is that a character? Yeah, it is a character. So you don't want to use a character. So if it's only 2 values, what will you use? A Boolean, right? You use a Boolean and you can pick either one. I use you can pick one to be male and the other to be female, doesn't matter. So what I usually do, I just pick this. Why? Because I type 2 less characters. You can pick if it's female or whatever, it doesn't matter. But I type less characters, that's all. So now, the rule said if age is greater or equal than 65 and is male, or age is less or greater or equal than 60 and is female, you get your 401k benefits without being taxed or whatever. So we're going to write an if statement that does that. So we can do it 2 ways. There's a way to do it correctly, and there's another way to do it correctly and efficiently. Alright? So your code might be correct, that doesn't mean it's efficient. Efficient means runs faster, uses less memory, and is easy to follow. and there's no copy paste all over the place. So let's do it how would you write it in the UML? It will say, well, let's pick one, the gender or the age. Well, let's pick the gender, it's the easiest one as well. Is male, right? So if the answer is yes, and if the answer is no. If the answer is yes, you ask age greater or equal than 65. If the answer is no, then you assume it's a female, then the age greater or equal than 60. Right? If the answer is yes, same as this one. If the answer is yes here, you can say retire. If the answer is no, I'll write it like this. So it's just no here, no here. You say work, and then here you continue with your program. It's getting messy, right? Well, you can do it that way. You can ask the questions here. If so, I can say is male true. I can do it this way. Else that is like that, technically correct. Now, male can only be true or false, right? Do I need to compare true equals true or false equals true? That's kind of redundant. I can just do it like this. That's true or false by default. That's all the values it will have anyways. So I can do it like this. Am I going too fast? Alright, so you can do an embedded if statement, what we call it. And then we can say if the age is greater or equal than 65, we do something. And here we have an else. And here we can ask age greater or equal than 60. So that's technically correct there. I can do, I'm gonna use this color. Here in the system, add out the print line, retire, right here. Work. And here, I'll repeat copy paste code, right? Which is terrible, because I have to write it again. And I don't have copy paste on the board. So this code is correct. It meets this. It matches the UML diagram. But is it efficient? Well, I copy paste code. If you do that, it's not efficient. And you need to get into the habit of not copy pasting code. If you copy more than one line, something wrong. You gotta rewrite it something else, or make it more efficient. So, how can we simplify this? Imagine if it's not one line here that I just system that out, the print line retired. What if it's 100 lines? So I want to copy paste these 100 lines there? Oh, that would be terrible. Well, I use a couple keywords here. I said and I said or. So we can do some combinations. So, we had the logical operators, we had the equals, greater, greater or equals, less than, less or equal, and the not equal, right? Those are, yeah.
For the second one, how do you know if it's like for female? It's just because
so this can only be two variables, or two values, right? True or false. If it's not a man, it's a woman, right? So, well, if it's not a man, what else can it be? No, I mean, computer, we're not, you're writing a program, it's not an open, I don't know how to say it. If it's not true, so remember when we talk about binary, right? If I have a byte, that is false, right? So if I have this, or I have this, is that true or false?
True.
They're all true, right? Why? Because they're not false. False is all zeros, right? So it doesn't matter if it's not a male. Yeah. So then back to this. You remember the order of precedence, right? Somebody told me a year ago, please excuse my Aunt Sally or whatever. I never heard that before until last year, and I've been teaching for 9 years. So, no, 8. So anything in parentheses goes first, right? So, there are and an or, you know that the not, this is not, right? I told you a minute ago. This is not, right? All negation, like we say it in computer science. Well, the and, there are two types of ands. When you're doing if statements, we're going to talk about logical ands. So if I only have one equal sign, what is that called? That's the assignment, right? But if you want to compare, use the double equals, right? So when you want to do logical and, we use the and sign. We use 2. That's called logical and. And if you do 2 vertical lines, which are the ones on top of your enter key, This is a logical OR. So I have 3 if statements here with duplicate code. I only want to have one if statement that takes in consideration the gender and the age at the same time. So how will I rewrite this? I only want to have one set here. So let's make this wider. I need to write something in there based on what I told you about using parentheses and the logical and the logical or. Tell me what should I write in the parentheses. I'm sorry, I can hear you.
The first one, you write the parentheses of is male, if is male.
So you want another parenthesis here. Is male,
The double and.
double and.
Then 65 or greater.
So the age greater or equal than 65, right?
Those are parentheses.
Close the parentheses. And then what? Or, so I put a logical or here, right? And here, what do I write?
I'm not sure if you have to include the is female. Since we already have the is male.
What do you think? What does it say then?
Well, yeah, I guess you would include the is female.
So how would you include is female?
Right?
Yeah, how would you write it here?
Parentheses. You already have the order, so it's is female and they.
How would you write is female? There's no is female variable. There's only 2 variables.
Well, then you would include is male equals false.
Is male equals false. Equals false, right? And age 60. Is that correct? I mean, does this if statement meets this? You think so? All right, so give it some values. So if I say age equals 55 and is male equals false. So the computer, there's 2 equal level of parentheses there, right? The orange and the red one. When they're the same, it's gonna do left to right. So it's gonna go on the left first. It's male. It's false. Now I know it's not male. Do I need to test the age? Okay, so when you have a logical and this is what the books explains, both have to be true for the overall condition to be true. So if I say it's female, so that means male equals false. It doesn't matter if the age is over 65 or not, right? It's already false. So do I need to evaluate this? No, it's already false. So what's the point of going to the other one? That is called a short circuit evaluation. What that means, if the first side or the left side of the and sign is already false, it doesn't need to go test the rest. Alright, so X is the parenthesis because the parenthesis is going to be false, right? And then it goes, oh, there's an or. Let's go to the next one. So now this one says false, or is male equals false. Male is equals false, right? This is female. So this is true. And then, because this is true, then I gotta go check the next one. Is 55 greater or equal than 60? No. So this is false, so it says false or false. It's gonna be false, right? Now if I change the age to 65, goes here, is male equals true or not? Is male? No, it's false automatically. So I exit this when it is false. And here, check. Is male equals false? Yeah, males is false, right? This is female. So this is true. And is 65 greater than 60? That's true. And this is an and, so true and true means it's true, right? So I have the orange side says false and the red side says true. So it says false or true. When it says or, it means either one, right? So this whole thing will be true. Follow me? So far it is correct. I mean, when we had the 3 if statements, it was also correct. Doesn't mean it's quite efficient. So let's change the gender. And I make this true. So if we read these, or read this as natural language, yeah, it should be true, right? The guy could retire. But the computer doesn't know that. Doesn't read English, it just reads zeros and ones, right? So we've got to check. Is male equals, is male? Yeah, it is male, it's true. Then I have to check the next one. Is 65 greater or equal than 65? Yeah, 65 is greater or equal than 65, so this is true. So the orange is true, and then this is the or. Does it need to go test the or, the other side? It's already true, because it's or, there's a short circuit, so it automatically goes here. Okay. Now, is this the most efficient way to do things? Do you think you can make it even more efficient? No? Alright, so if you see a person, you don't know the gender, see a person, it's 100 years old. Will that person retire or work? Do you care if it's a man or a woman? No, right? It's all too old to work, right? So, does it matter what gender that person is, if it's 65 or older? Do you need to check the gender if the person is 65? I mean, you can do is male, I'm sorry, equals false. So you know it's a female, so she's 65. So is the age greater or equal than 65? Yep, and she can retire. Doesn't matter what it is. What if it's 63? It's a female. According to this, she'll retire, right? 63 greater or equal than 65? No. Oops, I erased one by mistake. Then this is false. Well, let's check the or sign. Is female equals false? Yeah, it is false. So that means it's true. And is the age greater or equal than 60? Yeah, it's true. So this is true. So false or true? It's true. So now this is that's the most efficient way. Capiche? It's all fine and dandy when I explain it, right? So, we have the assignment operator, and then we have the logical equals, right? When we compare the values. This is the logical and the logical or. That means there might be something with one and one or. Let's see. You know what that's called? It can be an assignment and or assignment or, right? But I mean, you can assign an and. So this is called bitwise and bitwise. What is a bitwise and a bitwise or? So, can I erase this? Write it down? Okay. So, bitwise means bits, right? That means you're working with bits. 0 and 1. So if I declare a variable type character and I call it letter, and I say that letter is gonna be notice when it's single characters I use single quotes, when it's a string I use double quotes. A So, in memory, what do you think is stored? You think is the letter A? It is stored zeros and ones, right? And if I look at the ASCII code table, I can see what the value of capital letter A is, and it's actually 65. So I have if I look at bit position 0, 1, 2, 3, 4, 5, 6, 7, right? Those are 8 bits, right? So, in the number 65, what will be a number power of 2 that will be close to 65 without going over? 64. And what's that number? What power of 2 gives you 64? So, you know, okay, if you don't know, you say, okay, 2 cubed is 8, right? 2 to the 4 is 16. 2 to the 5 will be 32. And 2 to the 6 will be 64, right? So 2 to the 6 is 64. So 2 to the 6 is 64. There should be a 1 there in the 6. Alright, so the number I have was 65 and I subtract that 64. So what's left? 1, right? Okay, what power of 2 gives me 1? 0, right? So that means the others are just simply zeros. So that's binary for 65. So if I were storing an integer, it will be 65. If I'm storing a character, it will be letter A, right? So this is 65 and capital letter A. I'm just going to write it like that. Let's say instead of just 1, I have another one, have a letter, and have another. In this case, another is gonna be lowercase a. So in the ASCII value table, lowercase a is 97. All right, so what power of 2 is equal or less than 97? You had 64 before, right? Double of 64 will be 128. So that's too high. So in mathematical terms, I will ask you, what is the floor of the logarithm base 2 of 97? And then you will tell me, well, it's 64, right? So 64 actually is 6. 2 to the 6 is 64. So you put on 1 here. So if I have 97 and I subtract the 64 I had left, what number do I have? 33, right? And then you think, you do this again. What power of 2 will give me 33 without going over? 5. All right. Because 5 is, 2 to the 5 is 32, right? So what? So I subtract that. What number I have left? 1 again, right? So capital letter A, lowercase a, binary wise, they look very similar, except that this bit, if it's false, is capital. If it's true or 1, it's lowercase. Right? So we have number 65 again here. I'm going to write it here. And I have this. So, by the way, what is this number? 32, right? And I do a logical OR, I'm sorry, a bitwise OR. So I do OR. So it's a bitwise OR. So bitwise says, if one of the bits is 1, the overall is 1 in a bitwise OR. So I said 1 or 0 is 1, 0 or 0 is 0, 0, 0, 0, 0, 0, 0, and then 0 or 1 is 1, 1 or 0 is 1, and 0. So 65 plus 32, computer is simply doing a bitwise OR. What if I have this? What number that is? If it were all ones, it would be what? What's the highest number we can get in 8 bits? Well, you count 0, so it would be 255, right? And minus 32. So it would be 223, right? So this is 223. And I do a bitwise AND. Then it'll say, if it's AND, both have to be 1 and 1. So 1 and 1 is 1. 0 and 1, so false and true is false. False and true is false. False and true is false. False, true and false is false. True and true is true, and false and true is false. So it goes back. So that's the difference between a logical AND and a bitwise AND. So you wouldn't do this in Java, but that's how the computer does. If you want to do the summation, just simply ANDs or ORs them. So if I were doing a subtraction minus 32, well, this is the 32, right? The one is on this. Oh, sorry. This. But if I were to do a NOT, like reverse everything, so reverse all the zeros and ones. All the zeros to 1 and all the ones to 0. And then those is the AND. And that's your subtraction. You ever wonder how the computer does it? Now, there's a separate circuitry inside the CPU to do this. You know what that's called? Your CPU is that big chip that has the big heat sink and the big fan. And the CPU can do your graphics, but most computers now have a separate graphics card to free the CPU from doing that. It's called a GPU, right? Graphics processing unit. But also, the motherboards also have a separate chip to do math. So the CPU does other stuff. Well, they don't call it quite like math, they call it arithmetic. called ALU. It's a separate chip in the motherboard to do your math. We're good? Alright, let's take 10 minutes and then we'll continue with more logical stuff. Alright. So about more conditional stuff. So, in this class, I told you that if you got 90 or better, you get an A, right? You get 80 or better, you get a B. 70 or greater, you get a C. 60 or greater, you get a D. Less than 60, you get an F, right? That's your grading scale. So, what I want you to tell me is, what should you write in if statements to test for your grade? So we have global and character, and I'm gonna call this point, and this one grade, right? So you ask the user what's the point, and then you are going to tell me what the grade should be, right? So, let's assume point is, you got 85.3. Now, listen. Now, I want you to tell me what should I write for if statement. So I gotta do some if here, right? So what does the if say here? If I were a rich man, I wouldn't have to be working here, right? I will be driving a Honda, but it will be a Honda Jet.
You want it to be based on the 8.3 if?
No, I want you to based on this, your grading scale. Just this particular student has 85.3, but
Wouldn't you pretty much type of like fallback in one statement?
I don't know, you tell me what to write. Alright, I'll give you 5 minutes and I'm gonna pause this while you think. A what? An equation? No. We're not solving for anything here. Alright, so if, what do I write first?
If I didn't know what to write, so I just wrote my name.
What do you write? Well, the computer wouldn't know. So what's the first thing you're gonna test? Your points, right? Against what? 90. So you say points greater or equal than 90. Then what do? Then grade's an A, right? I could write the brackets here, it's fine. But what if it's not? Then do you get an F automatically? No. So I'm gonna make this simpler. I'm gonna make an else if here. You can put the else in the curly brackets and have a bunch of if statements inside, or you can just have them in the same line. And that's the next thing you compare is the points greater or equal than 80, right? If that's the case, you get a B. Or we could have done it like this. Let's do it the long way. Right, so we could have an else here. And then do an if statement here. Then the grade would be otherwise. I have all these embedded if statements. Do you get something like this? Can you try to do one? What do I write in the else here? So I go top to bottom, right? In this case, 85.3 greater than 90. Nope, it's false. Go to the else part, right? Is 85.3 greater than 80 or equal? Yep. So the grade is set to B, and then it just goes down. Because this is to this, right? So then it doesn't care about what's here. But let's say instead of 85, this guy was really skipping class and stuff, and got a 55.3. And then come ask me, can I have some extra credit? And I'll say no. And it's on the record now. It's recorded that I said no. So don't ask me. So, according to that, you should get an F, right? So, in here, after I tested for 60, should I do another if statement? Why?
Because it wouldn't really give you anything that you didn't write before.
So, when we did the gender, we said is male equals true. So if it was a female, if we say is male equals false, and then we did our steps first, we test for if it's a male, do we need to test if it was not male? Do we test another if? No. What else it can be? If it's not a male, what else it can be? It has to be a female, right? So in here, if it's not greater than 90, not greater than 80, not greater than 70, not greater than 60, do I need to test if it's less than 60? What else it can be? Nothing else. So, when I had is male before, right? And we had it like this, false. So if I had if is male, else, did I need to test here if it was not male? It's automatically not male. because it's false. It's not, if it's not male, it goes to the else part. So how many options do I have in the is male? 2, right? True or false. So how many if statements do I need? 1. I have 2 options, I only need 1 if statement. How many options do I have here? 1, 2, 3, 4, 5. So how many if statements do I need? I need 4. So the last one is just the default value. So I got 1, 2, 3, 4. So this, we call it default or trailing else if you want. So if everything else fails, that's the default value. We could write it, oh, notice I wrote it in descending order, right? I could write it in ascending order. How will I write it in ascending order? Well, I'll start here. If it's less than 60, right? We were testing greater or equal, so the opposite of greater and equal is less than, right? So if it's less than 60, you get an F, right? If it's less than 70, you get a D, because 70 will be a C, right? And if it's less than 80, you get a B. If you get less than 90, you get a, you get a B. Otherwise, it's automatically an A. What else can it be, right? But what if I do it in different order? What if I don't do it in order? What if I do it not in ascending or descending, but randomly? Let's say I swap these two. Well, if it's less than 80, you get a C, right? If it's less than 70, you get a D here. Would that give me the correct result? If I had, let's say, 85 here. What will the result be there? You test from top to bottom, right? 85 less or equal than 60, 85.3 is less than 60? No, goes to the false. Is 85 less or equal than 80? No. Alright. Well, this one worked. Yeah, let's do a different number. Let's do 65. That was a bad example. So 65, according to this, you get a D, right? So is 65 less or equal, less than 60? No. So is 65 less than 80? Yeah. You get a C. Boop, I'm out. And the student will be happy. Or it wouldn't be correct, right? So it has to be in ascending or descending order. Another way to simplify this, I don't know how many lines here, but I can simplify this. Oh, by the way, if your if statement or your else portion only have one line of code, you don't need to have the curly brackets. So if you forget to put the curly brackets, the computer will compile, but it will only execute one line. And the rest will be just part of the rest of the program. So you might get weird results. So as a habit, put the curly brackets. Once you get used to this, then you can take them out if you only have one line of code. So I can do it here. I can do all these else if in the same level. And then my trailing or default else is the same. You got names. So that's correct. Doesn't mean it's efficient, but it's correct. Now, notice something. In each if statement, what variable I'm comparing? It's the same variable all the time. When we broke this down, before we made it in a combined if statement, we have here age, right? So the second if was comparing something else. But in this case, all my if statements are comparing the same thing. And when you're comparing the same thing, you only need to evaluate one variable. And because you read the chapter before coming to class, you know what I'm going to talk about next, right? It's called a switch. So a switch is a more efficient way to do if statements, and it's cleaner. So the switch statement looks like this. You have a switch, and this is true in C, C++, Java, and JavaScript. It's the same. And then you have a variable here. Notice you could write an expression, but we won't get there yet. And then I have this opening curly brackets and I have this closing curly brackets. And this curly bracket means end switch, right? Now, this variable here has to be all numbers characters or string. It could be also something called enumerators, which we haven't talked about yet. So we're going to test one variable. There's no true or false there, it's just a variable. Okay? Of those types. Whole numbers, which means it could be an integer or it could be a long. It could be a character, it could be a byte. Yeah, I didn't write that. It can be a byte or it can be a string. Now, notice I'm not doing a comparison there in here. I'm just have a variable. That's it. Those types. What the computer is going to do, it's going to evaluate exact values. Why don't I have decimal numbers? Simply because, let's say if you're doing accounting stuff, if I have 35.0, you'll say that's $35, right? Well, what if I have 35.000001? It will be rounded to $35 exact, right? But binary wise, it will be different. There might be a rounding error somewhere. That's called a precision. And that's why switch doesn't work with decimal values. So, in this switch, I'm going to compare exact values. When I'm comparing to the exact value, I'm going to use this word case, or lowercase always. And I'll use a value here. And I'm going to use columns. And after that, I could have multiple cases. I'm going to add to execute. I will have a bunch of code. But when I'm done with that particular value, I gotta tell Java, okay, I'm done with this segment of code. And notice I didn't have curly brackets there. I had column. So how do I show where it ends? I'm gonna use this other word called break. When Java sees the keyword break inside a switch statement, this is a switch statement, it's gonna go to the end of switch and it's gonna execute the code, whatever, continue down. So I can have another value here, another case. Value 2, let's say. Another column. I'm going to have other code to execute here. And then another break. And it's going to continue as many cases you have. And if none of the cases fall in the one you're looking for, remember what we call this else? What did we call it? Look at your notes. What did we call it?
Default.
Default, right? That's the default value. So here, I'm gonna have a default. There's no value here, like in the cases. That means it's every other case fail, it's gonna go to the default. Default code if all cases fail. And then you get out. Questions here?
By the value, you mean like the points, like if we were to make it into the point scale, the points will be the value.
Is points whole numbers or decimal? Is this whole number?
That's the decimal.
Can we do decimals there? No. For instance, all right, let's make an example. So we did this code first, and then we're gonna check the grade here. The grade is a character, so we can test that one, right? I say case, and we can start with whatever value, A. And then I use column, and I can do system that out that print you rock, whatever, and then use a break. And I can test the next one. Do a case B. And I can say, I don't know. You all right, or something, I don't know. And on break. I can do a case C. So C is an average, right? Well, that's another word for average. It doesn't sound so nice, but that's what it means. Right. Mediocre. And break. Now we got a D. Say system, cut out the print line, print, need to improve maybe. Break. What will be my default? See ya again next semester, right? the same class, by the way. Right? I mean, you can say you suck, but I don't want to say that. So, the cases are exact values. I mean, if I do decimals, I will have to do 90.001, 90.002, however how precise you want it to be. That will be crazy, right? But what if I want to do a switch statement and do this into that? How will you do it? Can it be done, is the question. Moving the camera too much. Right. Can you convert this into this? I mean, you can do anything, but how would you do it, is the question. So, I want to do something here. That instead of printing things out, I want to evaluate the points. And what I want to do is come up with some case that I can say grade equals A, grade equals B here. Oh, by the way, on the weekend, I only noticed like 4 of you have done the first assignment. I don't know. Let's see how many people done it. Oh, I got 2 more. Only 3 people have done the second lab. Don't fall behind, because you're gonna get one every week. And you know, like every 3 chapters you get a project. And if you don't do this, you don't practice, I'll be seeing you again next semester in the same class, right? I mean, we don't want that yet.
They have like tutoring in the tech lab.
I think they do.
For this class.
So anyways, so how many bits is an integer? So it's 32 bits, right? So we got this chunk. We have a double here for points, right? How many bits is a double? 64 bit, right? So 2 sets of 32, right? So let's say I have 65 and point here and 3, right? What will happen if I drop these 32 bits? If I drop this 0.3 here, if I drop this other 32 bits. So instead of 64, it becomes 32 bit, right? So in other words, I round it down, right? It could be 65.0, it would be the same number, but if 65.3, I drop the 0.3, I just have the whole number part, right? Let's say I have a 32-bit, and I add another 32-bit here. And I have, let's say I have the number 35. If I make 35 into decimals, what it will be? 35.0, right? So basically, they're both numbers, right? I can convert a 32 to a 64 by adding those 32 bits at the end. Or if I have 64 bit, I can drop the last 32 bits and make it an integer. That's called casting. Well, casting actually is converting one type of variable into another. So converting an integer to a double, you add 32 bits at the end, it will have zeros. Or if you're casting a double into an integer, you simply drop the last 32 bits, right? To cast a variable from one type to the other, the way you do it is you put in parentheses before the variable the type you want it to be. So in other words, if I cast this point, I will do something like this. I will do parentheses. I want to convert this to an integer. That's the type in the parentheses. And I'm changing the points. So that's how you cast points into whole number. But basically drop the decimal value, right?
Does it only round down when you put it as an integer, or will it also round up?
No, what's happening? You drop the last 32 bits. This doesn't get changed. You just drop that. That's what it's doing. Just drop the decimal. So, if I were to do a system that print here, what do you think it would print? It would print 65, right? Because it points 65.3. Alright, so 65 is a whole number, right? So then I can use this switch. I can cast this here. And now what do I use for case? I don't know, what do I write here? What? So I put case points, case points, case points. What do I write in usually in case? I write the exact value I want it to be, right? So if I convert points into an integer, now I can evaluate the switch because it's a whole number. I'm using just, it's gonna do what's inside the parentheses first, right? And then it's gonna do the switch. So it's gonna say, oh, 65. So what do I write in here? Okay, so what does the case take? Does it take ranges or does it take exact values? Okay. So if it's exact value, you don't use less or greater than. So if this guy is to get a D, I mean, regardless what I have over there, if I have case 65, it'll work, right? But I don't have, well, what about 64? What about 63? Well, technically, you can have as many cases as you want. I can have, I'm going to put it next to it. It could be in the next line. I could have case 66. Hold on, it's not running it. And so on. But then I will have to write a bunch of them, right? That wouldn't be efficient. So how can I make it so I only test one? Any idea? You can modify it however you want it to modify it. So if I have points go from 0 to 100, right? So that means if I drop the decimal values, I can use the switch statement. If I use the switch statement, I have to do case 90, 91, case 92, case 93, and that would be a pain, right? And now this is not in any book. The book will tell you, or I will tell you how the syntax in Java works, but I cannot teach you how to think. You have to get creative. You gotta be ingenious. That's where the word engineer comes from, right? You gotta figure it out. So, what if I do something like this? Put a parenthesis here. That happens first, right? What's in parentheses? That didn't change anything. Right? And I do divided by 10. Well, I could do this too here. I can put the parentheses here. It doesn't make a difference. So I could do 65 divided by 10 or 65.3 divided by 10. All it is moving the decimal point here, right? And then I can do case 9, case 8, case 7, 6. Make my scale smaller. But what if you do all the homework, you got perfect score in all the tests, and even you do some extra credit, so you get 100 points. According to that switch statement, what will be your final grade? You get an F. So I will need to add case 10. And now this works. Any questions? Yeah.
It doesn't matter which order you put it in, if you would put case 10 and then case 9.
No, because now the cases are exact values. It's not looking for greater or less than. So then it doesn't matter if the 7 is above the 8 and the 8 is above the 6, it doesn't matter. Question? We're good? All right, let's take 10 minutes.